All right. Maybe nothing was live. Anyway, my name is Robert Starmer. I'm with Cumulus Technologies, and we're going to be going through some of the capabilities in the Istio space. Istio being a control tool for Kubernetes environments. We have a class that's on Udemy that covers this same material, and I'm actually going to be using the class, the course guide, to cover this just as a way of sort of helping us sort of focus on our conversation. If you're interested, I did post into the stream chat, or at least I hopefully posted into the stream chat, although I don't see it. I posted a link to the class that we have on Udemy, so if you want that, you're welcome to pop over there and grab a copy of that. But other than that, we'll go ahead and dive on in. You can see I'm already on section 4, our lecture 15, which is sort of where the labs really start. And we'll just run through this process. Now, I've already installed Minikube, but just for completeness, we'll go ahead and have a look at these instructions, right? So this is from the kubernetes.io page, Minikube instructions for installation, and there's VirtualBox and a bunch of other options if you want. We described the VirtualBox process, basically give you some links, go grab VirtualBox. I've already installed that on this machine. This is a Mac that I'm using, but it works on a PC as well, or even on an Ubuntu or Linux machine if you wanted to go that way. Getting kube control, it turns out Minikube will also install that, at least if you install it with Brew, which is the way that I did it on the Mac. Brew is a tool for installing non-packaged, so non-classic application, the way we think of it, tools within the OS X Mac world. But if you just follow the Minikube instructions, you'll also need the kube control, or kube cuddle is the way I've always heard it pronounced. Apparently kube control is the proper term now. And we'll go ahead and assume that you can follow those instructions, and then we'll go ahead and launch our Minikube. So this will start up a Kubernetes environment within our local machine. So here I'm running on a machine that has an i7 Intel i7 processor, and 16 gigabytes of memory, so it's got plenty of memory for this. You should be able to get away with like an 8 gigabyte machine and 2 cores, so like an i5 scale processor or something similar. Kubernetes is actually a pretty lightweight technology. The one difference here is that Minikube is actually launching a virtual machine and then running the code within that environment. Now there is another way for Mac and PC users. I think with Windows you have to have like Home Pro or Windows 10 Pro rather, not the Home version. But on OS X you can also do this, and that is to download the latest version, the Edge version of the Docker client. So Docker being a container management tool, Docker is also the underpinning of most Kubernetes environments these days. Docker for the Mac and for Windows, but Windows Pro accounts actually supports Kubernetes environment within the Docker management tool itself. So it's actually a pretty cool way to get Kubernetes, although this way I know works just about everywhere. So this is the way I usually recommend going ahead and grabbing a Kubernetes environment. Now, we're going to talk about Istio rather than Kubernetes, but I wanted to make sure that we had our Kubernetes system running. And for those of you that are just joining this or maybe watching this later that haven't seen Istio or haven't heard of Istio, Istio is a tool that is used in the service mesh community. So it's part of the service mesh community of tools. It's a way of actually building and managing a service mesh. Now, service meshes came out of the microservice development model, which is basically building applications that have RESTful API components, so ways of communicating in the REST environment. And Istio is a tool that provides a number of different components, from a proxy, which is important. It sits in front of each of the microservices and provides a whole bunch of control functions, provides that proxy function, and then the control plane for that. And we'll play around with specifically one component of that, which is the routing component. Again, we're going to jump into this now that our cluster is up. We can do a couple of things. Kube control, so kubectl get nodes. Let's just see if we can actually talk to Kubernetes. This is a standard Kubernetes command. Minikube is the name of our node, so that's the virtual machine that got turned on, and on top of that, all of the Kubernetes resources were put together. In addition to that, here on the Mac at least, the kube control tool is also configured by Minikube, so that way it knows what context or cluster it's talking to. We can do kube control config get contexts plural. That's because there are potentially multiple of them. And you can see I have the Docker for desktop context and I have a Minikube context. So I can talk to either of these resources and either of these Kubernetes environments just by changing that. But we want the Minikube one. That's the one that the instructions actually walk through and talk to. So here we can see that we've sort of gone ahead and run some of these commands. We're not going to do the stop or delete. That's how you clean up your environment. So when you're done playing around with Minikube, which is really intended for this kind of interactive work, it's I think a useful way of thinking about things. Oh, maybe I moved this too far. Let me see. Oh, maybe that's better. Maybe now you can all actually see my commands. Anyway, great. So we have Minikube running. And actually, let me just check and make sure. Is there anything in the chat? I don't know why I'm not seeing any chat. Well, if anybody wants to ask any questions, you can go ahead and ask them on chat. So we're going to go ahead and continue. So this was just some initial setup. Another approach is to actually do this in the Google environment. Google actually has pretty amazing Kubernetes capabilities. It's not only Google. Google has it, Azure, Microsoft's cloud, believe it or not. Yes, we talk about Microsoft again from a cloud perspective. The Microsoft cloud is actually pretty powerful for this. And you can actually set up an entire Kubernetes environment in Amazon, of course. You can do it in Amazon or IBM's cloud or Rackspace's cloud or any of the other cloud providers. But Google has actually a pretty nice little way of doing it. Here I'm actually logged into the Google console, looking at one of our platforms for deploying things. If you go to the Kubernetes or Kubernetes engine tab, you can go to your clusters page and you can say, hey, go ahead and create a cluster. This is really another quick way of turning a cluster on. You have a lot more control here, but if I were to just say go ahead and create one with the default CPU, one CPU or one core type system, it actually turns on 3 machines. So whereas when we did kube control get nodes, we got 1. Here we see 3, and we can go ahead and let the system do the rest of its things. We don't have to modify any of these and go ahead and say create. This will now go and spin up 3 virtual machines in the Google Cloud environment and install the Kubernetes node information, the node controllers on there. The control plane, so the system that we talk to with kubectl, all that is actually set up by Google automatically, so we actually don't have to deal with that. Now this is a for pay service, and while you can get some credit, you do actually have to consider the fact that eventually this will cost money. So great if you want to actually understand how you might go to production, but for just messing around, that's why we actually end up using the Minikube version of Kubernetes. Okay, so now we have a Kubernetes environment. And again, Istio is this tool for creating this service mesh concept on top of that. It certainly makes sense to have more nodes, but really what we want to do is attach to multiple microservices. So I'm going to skip over the GKE instructions. Again, they're all there for usage. You can actually follow that process if you want. The next thing is we need Istio. Without Istio, we don't get very far with this whole process. And there are a number of different ways of doing it. This is basically a script. So this particular command or this particular page that we're asking for, if we actually go look, it's a shell script, and we can actually go look at that raw data. That shell script takes some inputs, including things like an environment variable to describe which exact version we want. If we don't do that, it'll pick the latest release, and that's actually this here command. It's always good if you're looking at a shell command or something that looks like it's going to do an installation from a shell command, that you maybe actually consider looking at what that shell command might be doing for you. And you can see here it gives you some instructions on how to actually pass a specific version. We're going to pass a specific version just so that we have consistency, that we make sure that the instructions work because they map to the same version of Istio. Anyway, so always good to look at what command you're running, but then we can go ahead and run this. Now it turns out I've already done this. I've downloaded the Istio version, and that creates an Istio directory. So we can actually go back here, and it turns out I'm even in that directory. So so here it created in my users directory, I have an Istio 051 directory, and that's where I'm starting from. And so then the instructions sort of kick off from there. There's a lot of information in here about where you are. You do also want to make sure that you have the path exported. This is different on a Mac system versus a Windows system, but it's also possible to do all this on a Windows system and run these commands from there. But exporting the path is a little bit different. If you have questions about that, go ahead and drop me a note. We'll follow up on that. But the most important thing is launching and installing the actual Istio tools themselves. And luckily, there's effectively one manifest that does everything, or at least most of the core resources. And in this case, we want to actually enable different resources. So we're going to go ahead and run some of the key commands, well, specifically this command, which is going to do most of the installation for us. So this will get our control plane set up. It'll handle the core resources for our control plane: pilot, mixer, ingress, and CA. And once the control plane's set up, it turns out that we don't create a mesh until we actually create an application. So we're going to use one of the Istio, or we can use the generic Istio default application, which is the bookinfo application, to actually go ahead and install and run through a bunch of these tools. So let's go ahead and jump into that. So the first thing we're going to do, we're in the Istio directory. So after it gets created, I change directory into the Istio directory, and we're going to go ahead and apply this manifest. Now, again, it's always good to have a look at what you're doing before you do it, especially if you just downloaded this from the internet. So we can go ahead and look at what's in here. We can see that there are a number of resources. So this is a Kubernetes manifest specifically intended to configure Istio, install the right resources, and then install the pilot, which is the control plane, the mixer, which is a data collection tool. It's used for the metrics gathering, the CA cert, which is actually now called Citadel, etc. So it basically installs all the core resources for an Istio control plane. The first thing it does is it creates a namespace, a way to sort of separate those things out so that they don't continue to clutter the control environment. Sets up a bunch of roles-based access rules, sets up roles, installs resources, etc., etc., etc. So all this gets done. Great. I actually do trust the installation in this particular case. So I'm going to go ahead and run that. And you can see it goes and creates all these different resources and services, and then we can check and see if that actually got created. So we can do things like kube control, get our services. We do have to pass the Istio system namespace. And we see that sure enough, here we go, the ingress controller has been turned on. Now it's trying to use a load balancer type. Minikube does not have a load balancer type, so this will always remain in pending state. But that's okay, because we're really making sure that pilot and mixer are up, and so we have the core pieces available to us for our Istio environment. So great. Once all that's done, we can see that the key pieces are running, and we can go ahead and get the system up and make it useful. So now that that's running, we can do sort of our next step, which is to actually deploy the bookinfo app. Now this is an application. Actually, they have a nice little diagram here, or we have a nice little diagram in our class. Bookinfo application with without Istio, so this is just the application and the intent of how this application runs. Istio basically just inserts itself between each of these connections, communications paths, and that's really the point behind the service mesh. It's basically giving you additional control on top of your application. Right. So here the concept is requests come into the system. There's a Kubernetes pod, which is basically a way of managing a container or set of containers, pod that is managing a Python application that lives in a container. And that application is a Flask application that provides a web front end. We have a set of Java containers in their own individual pods, and there are 3 different versions of the reviews container. So basically 3 versions of an application. So as you go through and continue to develop it, you might have multiple versions. You might even want those multiple versions to be running at the same time if you want to do sort of like a blue-green deployment where you have one version that's running and you have the new version and you want to migrate people from the old version to the new version. Being able to run multiple versions is important. This application was developed specifically to highlight how Istio works. And so one of the things that happened is that the reviews version 1 code doesn't actually have a way of presenting ratings information. So that was the first sort of bug in the system, and we wanted to fix that. So reviews version 2 was created, and then a ratings service was added, and so that's now in yet another language. So we can see we have Python and Java and Ruby and Node, and that's actually one of the reasons that people started to build these service mesh environments anyway. Was I might be able to create communications tools that let me do the kinds of routing and authentication and service control that service mesh does, but I would have to have the right set of libraries for every different language that my development teams might use. And in this case, that means that I would have to have 4 different libraries or 4 different language bindings to be able to do this, because I have 4 different languages defined. There are very few communications tools that have the same kind of bindings and capabilities across multiple languages. And the service mesh does this not by having multiple libraries for all these different languages, but instead injecting itself next to all these resources. Basically, it provides the communications manager for all these different services as one language. Now, it turns out that it's written in Go, which is one of the faster languages today for these kinds of services, but that's almost irrelevant. We don't really care what language it's written in, because we can continue to develop the way we were expecting to develop and now leverage these resources. So anyway, one of the things that we're going to do as we launch this application, which is it's a Kubernetes-based application, which means that it's very easy to launch. We just have to define a manifest that has this information in it, and it launches all these services. We're going to actually launch all of them. And one of the things that we're going to do is we're going to actually inject Istio into this. Now, what that means is that we're actually going to basically put a proxy in between all these communications paths. And that proxy is part of the Istio environment. We do that using the Istio control tool, right? So what this will do, Istio control kube inject says, hey, I want you to take a set of Kubernetes manifests and inject an Istio sidecar plus all the control information needed to make sure that sidecar becomes the forwarding path for all the traffic. Now that's great if I want to run this command, which actually I will, just so that you can actually see it. Copy. Go back to our page here. Go ahead and say, let's go see what this does. Well, what it does is it spits out a manifest. Now, spitting out that manifest is great, except that that didn't actually do anything other than do this injection. And specifically, you can see here where a new portion was injected into the individual path, right? So basically, an Istio component gets injected, in addition to which additional annotations are added to the actual resource. So this is a deployment for the product page version 1, and a deployment is a Kubernetes environment that actually manages scale and manages resource lifecycle. So if I wanted to have a different version of this, I can tell the deployment to change from product page v1 to product page v2, for example, and the rest of the system will be able to handle all of that interaction. But specifically, what ended up happening is Istio injected itself into this document, and actually we can see that's true, because if we look at the file itself, go all the way to the end, right, here we don't a second. Maybe I overwrote this one already. Oh no, so the injection is actually the fact that the resources don't have, even though this router is here, we can see that the spec template doesn't have the Istio control that was back here injected in it. Oops, where is it here? Yeah, here we can see there's a lot more going on because now we have this sidecar annotation and the extra container injected in it. Sorry about that. I confused myself. So this information, this extra Istio information for the proxy was not in the manifest for this particular resource. Right, so this deployment didn't have all the information in it, and now it does with the Istio control component. Now, that's all great. What we actually want to do is actually launch this. And so now we're going to tell kube-control or kube-cuttle to apply the file, and we're going to use the Istio control injection. So this is a Unixified injection process. There's no equivalent here for the Windows users amongst us. So if you're using Windows, you end up having to run this command and output that data into another file, and then you can apply that newly generated manifest file in this fashion. And so we're going to do this since we're on a Mac. We can do it this way. And so now you see a number of resources are created, and one of the things that we can see, kube-control get pods, we can see that systems are in init status, but the goal is that we have 2 containers here. If we had actually launched this just using the default manifest, we would see there would only be 1 container in each environment, and that would be the just the application container. In this case, we now have a second container, which is the Istio proxy that sits next to each of the actual applications in our environment. And now we see we have the product page. That again, that's the front end resource. We have our ratings engine. That's the back end resource. We have a details service. That's actually what's keeping track of what books we're looking at. And then we have our 3 different versions of the review service, version 1, version 2, and version 3. So that gives us our running system, and eventually we'll have 2 containers ready in each of the pods, and that's both the application and the system itself. So this is going to take a little bit of time because it actually has to pull down these containers from online to actually launch this system. And so now we get to sit here and wait for a minute as this continues to finish its process. Here I've added the -w command to our kube-control, and so it'll sit here and wait for these systems to change. And as anything changes, it'll update the status for us. Otherwise, it'll just sit here and do nothing. So hopefully this is useful so far. Obviously, if you have any questions, if you're live, you're welcome to drop them into the chat. And I believe I can see the chat. I have a chat window open, although I haven't seen anybody say anything, so I'm not sure that I'm actually getting those messages. Other than that, if you have questions after the fact, we are going to be dropping this onto our YouTube channel, our 5 Minutes of Cloud YouTube channel. And so for longevity, this will be around there for a while at least, as a part of keeping track of sort of historical context. Again, hopefully this is useful, and we'll be doing these more often, just to allow more folks to sort of keep track of what's going on within the cloud system space. Again, as we're waiting for these to launch, once they're up and running, we can go ahead and look at the next page. So now we want to actually start talking to these resources, and we can actually try to get access to the Ingress resource. So we'll actually check and see if we can talk to the system. Is sort of the next task we have here. I'll go ahead and grab this. Maybe. I won't grab that. Try to refresh the page. All right. It's a little inconvenient, but certainly was able to get a hold of that data. See how our system is doing. Okay, so we're starting to see things running, so this is good. Is everything running? 1, 2, 3, 4, 5, 6. Yeah, it looks like. So I stopped the watch because watch will keep doing it forever. It basically, sort of gives you a view of the state of your system, a graphical overview, as it were. All right, so here we have these resources. This is all running, and the next thing we wanted to do is we wanted to be able to talk to the product page. Now, in the Istio mesh, because all control is run through that mesh, we actually have to use the ingress controller to talk to the environment. So let's see if we actually get a URL for the gateway here this way. So this is doing a bunch of things. It's actually running kube control, looking for the ingress pod in this Istio system. It's trying to get the host IP for that resource, and then it's trying to get the node port as well. So what this should do is if we then say echo gateway URL, has to be $, because it needs the variable. So if we talk to this address, we should actually be talking to the Istio ingress, and hopefully we will actually get our dashboard. Let's see if this works. I think this is where I have to go do some tweaking. All right, so we need to change this. Edit service. So the problem is that this is being defined as a load balancer, and unfortunately that's not going to work for us because we don't have a load balancer resource within this environment. So this would work just fine in the GKE model. So instead what we're going to do is say, hey, why don't you use the node port type? Oops. You know what that'll hopefully do? See if it actually accepts it. All right, so it has accepted it. Then let's see if the service is now happy. All right, so now it's node port. It actually has an IP, but we want the host IP, and so we're going to rerun that that export gateway URL. So it should give us the same data, I believe. All right, so that looks promising. Hopefully. Minikube IP. All right, so we're actually going to try this address instead. All right. All right, well, it's almost doing the right thing. I think maybe we have to restart the service, though. 279, so that looks good. Right. So we're getting the right node path, but we're not getting the right host IP. See, we're going to, well, this is where it gets fun, right? I think what we're going to do so basically what I'm doing is I'm deleting the resources that were created, given that the ingress for Istio was effectively wrong. So we're fixing we fixed the ingress. It's now node port type, so it's happy with that. We should actually be able to talk to the ingress. That's actually why we got no response here, right? It's talking to the ingress controller, and it knows about the port, but there's nothing there. So the service mesh wasn't actually connected properly, and I think it's because it was connecting to the wrong service initially. So it's possible that now, given that the ingress is defined as a node port type, so we should still have get service and Istio. Istio system, not source, service. Right, so node port type ingress controller. It has an internal cluster IP, that's fine. There is no external IP, that's correct, because it isn't actually presenting this thing externally. It knows how to deal with 80 and 443 type traffic, and sort of maps that into that resource. So that should all be fine. Now if we go and instead of deleting our thing, we'll go ahead and apply this again. So again, we're injecting our Istio control plane into the bookinfo application. And the resources are now up and running. I have to go through their init process. This should actually go a little faster because in this case we don't have to re-download those particular containers, we're just relaunching them. So everything's running. That's perfect. We can go ahead and look at services that exist, and you can see that we have a number of services. Might as well get all. All right, so we see we have the services that were defined. These are all the different individual resources. We also want to see, it's another way of looking at these, the replicas and the deployments. So that's all up and running. So now if we run our gateway export again, which was here, right, again we're looking for the ingress host IP and the service port, and then that's interesting. I don't think this will respond. Well, I might as well try this version of Minikube. I'll go ahead and version 1.9 instead of 1.10, because there's always a chance that that's the problem. Right. So we restart. Okay. So we're going to start. So this is starting a 1.9 cluster instead of the 1.10 cluster that I'd started previously. 1.10 being the absolute latest version, but we'll see if maybe one of those plugins. No. I don't see that that actually changes anything. Because all these resources were running, it's just that our ingress isn't working. So Alright, Istio, great. Yeah, so basically this is exactly where we were as well. Excuse me. All right, well, wait for this system to come up. This will take a minute because it does actually have to download the older version, the 1.9 version with this particular deployment. And unfortunately, because it's basically deleted the virtual machine and recreated it, even our bookinfo deployment is going to take a little while. But I think it's worth sitting through this, and we'll get this up and running. All right. Getting close. Getting close. Okay, come on. This will start eventually, I'm sure. Anyway, once we actually get started here, once we get through relaunching this environment, get our bookinfo app back up, we can actually start playing around with some of the routing. Might not be able to do that today because I only allocated an hour this morning to do this, but we will get back to it. Maybe we'll do a follow-on recording later this week if there's some bandwidth to do that. In either case, the instructions definitely work on Google, and I think it's just a matter of us finding the right address to talk to on our minikube cluster in order to actually talk to the ingress controller. Because once we're talking to the ingress controller, we will actually be talking then through that to the bookinfo app, which will let us see all the different services connected. So close. Come on, cluster. Interminable waiting for things. This is the part that's always painful. On top of all of that, I think our 192 address, the minikube address, so the minikube IP gives you the address that VirtualBox lets you talk to minikube on. That may have worked, given the fact that we actually got a blank page back. I think the little product page service probably ought to auto forward, but it doesn't seem to the product page in the service. So as soon as this is up, hopefully within the next couple of minutes, we might actually be able to get to the point of actually seeing the application run. Now, of course, this doesn't prove to anyone that we're using the ingress controller or using the Istio application for any of this, but we'll start looking at that if there's time today, or again, we'll do another recording in a little while, or another screencast in a while, and look back at this material somewhat more. Again, for those that are watching, if you haven't, the material that we have is actually put together on our Udemy class. The link is in the chat if folks are interested in that. You can get those Udemy classes pretty cheap for the most part. Usually they're $10, or there's a discount or what have you to get the class. Much of this information is also available in other tutorials around the web as well. So lots of ways to get it, and obviously, we've been doing it here on screen. So lots of ways to try to follow along, and we'll slowly get there. Maybe if this cluster starts, come on. Okay, well, if this doesn't start in the next minute, then I think something maybe got stuck, and I will just restart again with the 1.10 version. just going to redo this again this way. Anyway, I'll be back in just a minute. I'm going to grab a glass of water. Actually, I think since it started, I'm going to go ahead and launch the... So we should be able to get nodes. There's our node, yay. And then we'll go ahead and relaunch our bookinfo YAML. All right, so, oops. Oh, that's right. We have to launch Istio first. Go ahead and get Istio up and running. Obviously, that will help. Watch for that to finish, and then we can launch our app. Progress. Slow, but some progress. All right, so this shouldn't take too long, but again, one of the reasons that this is happening is it's got to download these containers, and so we see that they're slowly going to start launching here. So again, ingress controller, that's what actually allows data into and out of the Istio environment. Our CA, which is our certificate authority, Citadel is what the current name for this is, which is a spiffy certificate manager. Mixer is the data collection, so this is capturing metrics and other information from each of the proxies, the edge proxies, when they get deployed, and Pilot is the control plane. And actually we're waiting for 4 to run, now 4 are running, so we're good there. Alright, so our Istio control plane is up and running. Oh, that's right, I'd actually gone ahead and edited the ingress, right, so we can do cube control, edit service, Istio ingress, and it's in the Istio system namespace, and we want to find load balancer, node port, actually okay, so now if we get our services, Istio system, type fast. We see its node port type, cluster IP is defined. It doesn't try to get an external IP, so our ingress server should be running. Now our application is the next thing we want to do. So let me jump back here. Again, we're going to inject Istio into our bookinfo samples, and we're going to apply that data as a kube control process. Okay, now all these resources are created. Kube control get ingress. Great, gateway's up and running. It thinks it's happy on port 80, which is what the application thinks. We can then go run the export for the gateway, except I'm going to change this a little because I'm actually just going to grab the yeah, I'm just going to grab minikube's IP. Echo $gateway. Well, all right, so we have a different port this time. Now, I believe if I got this right, product page or product pages. I think this is correct. Ah, great. At least now we're talking to the ingress controller. That's fine. So our resource isn't running, and actually I forgot to check. Kube control get pods. Yeah, so they're still initializing. This is fine. This is where we should have been as of 15 minutes ago. Silly delay, all because I forgot about the product page component, and I think that's in our instructions. I just didn't. I sort of jumped ahead. Silly me. Anyway, so we'll actually update the instructions to grab the minikube address here for minikube resources instead of that. And sure enough, here it even says this is what you want to go and ask for. Robert, you're just too fast for yourself. So actually, we can go ahead and watch this. Watch for these pods to finish initializing. For them. So again, this is downloading this code. Unfortunately, the reviews pods are actually fairly large because they're based on Java, and this is one of those things that I often rail about, which is really doing the right thing for the right environment. And I think it's important to look at containerizing applications that make sense. Now, part of this demonstration was the polyglot language. So the fact that here are a set of different services all being stitched together with different languages. We have Java, and we have Node, and we have Python, and I think there's even one more in there, Ruby, all as application components of this environment. Here, so finally these containers have been downloaded and they're up and running. Well, this one's up and running. We'll give the rest of them another minute to do so. Details app is running. Even the Ruby containers, I think, are actually fairly large. There are reviews, product pages running. So that's 1, 2, 3, 4, 5, 6. That's our services. Okay, great. Now let's see if maybe now we can say hello. There's somebody there to talk to. So it's thinking. Okay, it might still be connecting. And there we go. Finally, we have our application running. So this is actually not just the chain of services, but the application itself is all connected. With that, I'm actually going to have to sign off for the day. Now that we have the system running, we will come back and actually look at some of the next things. Yeah, we're now here, so that's great. Like I said, we're going to update our page here so that we actually grab the minikube ingress, unless you're actually using the Kubernetes environment or one of those where it's a little bit easier to get that address. And we'll sort of take things from there next time. I think I'll try to do this again. Hopefully tomorrow we'll continue on and actually start looking at, for example, the routing rules, looking at forwarding, blue-green routing, some of that sort of stuff as a part of this process as well. Hopefully you guys found this useful, and certainly let me know. Feedback is always appreciated, and we'll look forward to talking to you guys about this next time. And again, this is just me signing off. Thanks so much for